So welcome back to the Python tutorial seminar series. Hopefully everyone watching this has already attended or watched the recording from our first 3 sessions, where we set up our workspace, we parsed a .text file, and we computed Windchill index. So if you've had technical difficulties getting through any of those steps, hopefully we were able to set up a meeting time with you, get you up to speed, work through them together so that you're able to participate today. And today we're going to focus on some string formatting of our output from our Windchill index function. And we're going to go on to more functions. Specifically, we're going to compute heat index. Here's just a little bit about myself. Hopefully you know me by this point, and I look forward to seeing you at this and future tutorials. And before we begin, I need to review our code of conduct. So by joining this Zoom call and participating in the tutorial seminar series, you've agreed to adopt these values and engage in respectful communication only. Any inappropriate remarks will have you removed from the call. And hopefully we don't have to worry about any of that. And the seminar is only an hour long, so you can ask questions throughout and I'll address them when I'm able. But there'll be some dedicated time at the end to get through all of your questions. There also are some co-hosts in the chat that will be able to help you as well. All the commands are on the NCAR Python tutorial website. But I also want to direct you again to the same learning resources as in the past. Stack Overflow is your friend, and Project Pythia is a growing resource designed to teach atmospheric scientists how to code, and hopefully you can find some help in the resources there as well. So last time we computed Windchill index, and today we're going to finish up what we started, which is going to have a heavy focus on string formation. And then we'll push our work up to GitHub for the first time. And then we'll move on to our second function, which we're going to compute heat index. And if we have some time, I think this is kind of where we're going to end, I imagine, but we will start after this refactoring our code so that we can pull out redundant blocks of codes and just repackage everything into a nicer, cleaner, more readable way. So that might be what you look forward to next session, or we'll get a little taste today. We'll find out. Heat index you see here is basically a power series expansion in 2 dimensions with a whole bunch of constants, 9 to be exact. But with that, let's begin. So just give me a second here to transition over to a terminal, and you should go ahead and open up your terminal as well. Okay, almost there. Okay, hopefully everyone can see that all right. So in your terminal, first we need to move back into the directory of our project. So for me, that is in my documents folder. And it is in, that folder is within the Python tutorial _22. I spelled that wrong. There's been a little glitch on my keyboard lately where sometimes the P and O are kind of linked right now. That is not going to excuse all of my spelling errors today, all of my typos. But I kind of noticed a trend. Okay, so once you're here, you can do a little ls to make sure everything looks familiar. We have our data folder, we have our mysci.py script. And don't forget, very important, activate your environment with conda activate and then the name of your environment. And you'll see that our environment is activated. Hopefully this stuff is feeling familiar to you after all of these past weeks. Again, this is week 4, or welcome back. And now let's go and look inside of our script. remind ourselves where we were. Okay, so first off at the beginning, we have a dictionary of columns that has the keys date, time, temp out, and width speed mapping to the relative indices that they have in our text file. Then we have a dictionary of types, which has the keys of temp out and wind speed mapping to the type float. And so anything you want converted from a string to a float is going to have a key here. You could also, if you wanted things to be converted to an integer, you could have your new key mapping to integer. This is just going to map anything that is not the default string. Okay, sorry if my audio is cutting out. I'm at the NCAR building and the Wi-Fi should be good. Let me just give it a quick check before I move forward. Okay, I'm on the internal network. I'm going to go ahead and turn my video off, so hopefully that can help with any of those problems. Okay, hopefully this is still engaging enough for you. Okay, so after we have our types dictionary, we then go down and initialize our data as another dictionary that has the keys corresponding with the keys in our columns dictionary, all mapped to empty lists. We open up our file with the with open file name as to read. We basically skip the header, and then we append every split line that is from the index we want, change the type, and we add it to the corresponding list in our dictionary. Okay, so that was our reading the data. And then we estimate wind chill with our simple one-line function here. We call it up with our zip here to create a tuple and append it to our empty wind chill list. If I'm missing anything that you guys are still confused about, feel free to speak up. But what I'm going to go ahead and do now is point out that we're computing wind chill, and that actually was a column in our original text file. So we can go ahead and pull out that value and compare it to what we have. So I'm going to go all the way back to the top and add it to the end of my columns dictionary. So I think that was let me see if I can remember how to get to the end of that line. Should be Control E, so let's try that. There we go. Hopefully that works for you too. And then inside your curly bracket, add a comma, and then two apostrophes for our string, for our key, and this is going to be wind chill. And this exists on the 12th column. Okay, and then wind chill is also a value that we want as a float instead of a string. So go ahead and add it to your types dictionary. And then you'll see that because we have this set up in such a way in reading the data file, we don't have to change anything else other than that. So we'll kind of scroll back down. We've computed wind chill. And we are now going to print out our values and compare them. We're going to do this in a debug section. So go down to a new line, add your comment. And how this is going to work is in a for statement, a for loop. So for, we're going to do another zip of our data. So we want a different name for the wind chill that we calculated and the wind chill that is from the data file. So let's call it WC_data for from the data. and WC_est for the estimated wind chill values. And this is going to be in a zip, just like before, to create our tuple, where we have our WC data value is going to be looping through the wind chill list within our dictionary, which we access like this. And the estimated is going to map to the wind chill list that we created just a few lines above. So this naming might be slightly confusing. Hopefully this emphasizes the importance of good naming for your files and for your variable names. We just want to make sure that we're consistent here. And for all of these values, we're going to print them and print the difference between them. So indent 4 spaces, 1, 2, 3, 4. We have our print statement, open, close parentheses. And I believe this is the first time we're going to show you what is called an F string. So you're going to do F and then open and close your string. F strings are a special symbol that lets you format your strings. They are not a function. And this is something that is new as of like Python 3, I believe. I don't know the exact release, but it's a great tool, very helpful. We use them all the time. So basically how you do them is everything that you want to be able to format has to go inside of curly brackets within your string. And so first we're going to just print the data value from the file, and our formatting options look like this with the colon and then .5f. The .5 here means 5 points after the decimal point. So that's kind of the accuracy to which we want to see everything when we print it. And then you can add some more spaces just to space the values out, make sure that you can visually see the difference. So just for consistency between everything, I'm going to do 4 spaces again. Oh, this actually is still within the apostrophe. Like so. And here we're going to do the same thing for our estimated wind chill. 4 more spaces. And then we want the difference between the two. So you can actually compute values within your curly brackets. Like that. Okay, hopefully everyone has time to see this. I can also just go ahead and I'll copy and paste that print statement here into the chat for anyone to see. I'm going to go ahead and execute this code and see what our values look like. Okay, yes, save changes, keep the same name, and then Python mysci.py. Okay, great. So if you remember, the left is the data from the data file. The middle column is our estimated data, and the rightmost column is the difference between the two. Now, since I know there's a lot of atmospheric scientists in the room, you might know that wind chill index is only valid over 50 is only valid under 50 degrees Fahrenheit. And this is actually from a hot summer day. So that's the cause of some of these discrepancies. I'm not sure, honestly, where our data is getting their values from, but they must be using a similar formula. We have some larger differences in some places. I'm mostly trying to teach you how to code, not the atmospheric science behind all of this. But comparing data is a normal part of any of your scientific workflows. So this is just a, starting example. Okay, If you did not get the F strings to work for you, check that you've updated your Python. Make sure you are in a new enough version to have F strings. Make sure that you've activated your environment. Oftentimes, if you are actually in a different environment that doesn't have something at least as new as Python 3.6. Okay. And another note on strings that I'll just go back in here and show you is that it doesn't really matter, again, if you use double quotes or single quotes. So here we use single quotes. If you use double quotes instead, just fine, as long as you're consistent. And a reason you might want to be able to do that is, say you want to print a string that has an apostrophe in it, like I'm a string. This would be valid, but something like this would not be. Hopefully that makes sense. Okay. Okay, so let's do a Git commit real quick, and then we'll move forward with printing out our data in a way that we like. So git add mysci.py, git commit -m, and then your commit message. And we are comparing win chill factors. Do a git status, so you can check that it happened. And I'm going to do a git log to kind of remind myself. Okay, so last time we did do a git commit with that same message, even though we didn't look at the printing of the values yet. So you can use a different message today if you haven't already gotten there. Something that's more accurate, like, oh yeah, so we have compute wind chill factor from yesterday and then compare wind chill factor from today. If you see that little colon and you're trying to scroll and get out of it, you can do a colon Q and then enter, and that's your quit, so you can get back to your normal terminal line. Okay, so now let's do a little bit more of our data formatting. Go back in with nanomysci.py. Come back down to the bottom. And this is no longer a debugging. This is now going to be a permanent part of our script. So let's give it a new comment. Instead of debug, let's call it output comparison of data. Let's see. We're going to want to print the date and the time and all of that. So the first thing we'll do, I'm just going to go ahead and delete these lines and start fresh for us. Let's create a new variable called zip data that has all of our data zipped together so that we can have a nice smaller line, since we're going to be zipping lots of more columns. So call the zip function, and the values we're going to pass into it are our date column, our date key from our dictionary, time piece, the wind chill, and our actual computed wind chill, or estimated rather. Okay, and so we're going to go for date, time, wind chill, data, is that what we called it before? And then wind chill estimate in zip underscore data. So you can see if we didn't create this a separate variable, this would be a very long line that would be hard to read on some text editors. Indent 4 spaces. We're going to compute our difference. That. And then we're finally going to print it. So again, we're going to do the F strings, and we are going to open and close curly brackets for every variable we want in here. So we're going to do date, time, our data from the file, our estimated data, and our difference. Okay, missed the curly brackets on this one. And now as far as the formatting goes, let's see, date we can leave as is. Time, we're going to do this : greater than 6. So that indicates that you'd like the characters of the string to be right justified and take up 6 spaces. For our wind chill data, we're going to want our original data from the file and our estimated data to both have the same formatting. And based on the values that we have, we're going to do 9.6F. So this means that we can fill a total of 9 spaces and a precision of 6. So 6 places after the decimal point. So 1 before the decimal, or 2 before the decimal, space that is the decimal, and then 6 after. And I know this can be a little confusing, but luckily with F-string formatting, you can play around, see what works with you. It's fairly well documented, and you might have a template that you like to use for all of your code. So this is just an introduction to what it can do for you. Another very popular use of F-strings is to say you had a list of names and you wanted the same email to have a different hello name at the beginning. You could use something like F-string formatting to just cycle through the variables right there. You would do that in the curly brackets, just like this. Okay, and then this one, let's do 10 places. Yes, okay. And you can do a different number of spaces if you'd like. This is just as kind of a starting place. So before we print our values, let's actually print a header to go along with it. So I'm going to do that up here. We're going to have a new print statement inside the string. And I'm going to start with a bunch of dashes to kind of be a separating line. And so first we have our date, which is actually going to take up 7 dashes takes up 7 spaces. 1, 2, 3, 4, 5, 6, 7. And then 4 spaces. We might have to go in and tweak this a little bit. That's okay. We set time to 6. We set our data to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And our comparison to 10. So that's just going to create a nice little header for us. And now we're going to actually want to print what we want the header to say. Okay, so first we have date. I'm going to kind of right justify these and capitalize them, but you can do however you like. So their time, so the E is lined up with the last space. Wind chill. These are both wind chills, and this is our difference. Let's add another line before this. To clarify our wind chill. So you can just kind of add a bunch of spaces until you get to here, and we can call this like data file or maybe original. And then estimate. estimated. And you can close it like there. Oh, I missed an A. What line would that be on? Date, time. Oh, I missed a colon right here. Like that. Yes. Yep, I did miss a colon. Okay, so let's go ahead and print this out and see what it looks like. We'll leave this for another second, make sure everyone's had the chance to get it. Again, we might have to edit it. I'm not exactly sure on the spaces that we picked, but they're consistent and that should be good enough. Okay, so we have our date, our time, our wind chill, and our values. Let's just scroll all the way up so we can see our header. Okay, great. They're lined up with our values. You can kind of see if we are saving this to a file, it'd be great. On the terminal, having to scroll all the way up to see the header is not ideal, but this is just what the output would be. So now let's do one more Git commit now that we've learned some F formatting. And then we're going to go practice pushing up to GitHub. So I'm going to do a clear. Git commit -m. Oh, wait, sorry. Git add mysci.py. Git commit. And we're going to call this output formatting comparison data. Oh, I didn't have a space between my dash and the end of my word commit. Okay, Git status. Okay, if you're getting the error invalid decimal literal, there is probably a typo somewhere on your script that I can't delve through with you right now. Hopefully we'll be able to have a chance to fix it as you see the script again, or maybe the error message is pointing you to a specific line that you can use to look for. And maybe a co-host will be able to help you more with that since it's going to be very individualized. Okay, so before we push this out to GitHub, we are going to rename our script to something a little bit more meaningful. Instead of just mysci, which is a generic first Python script, we're going to do a git move. And the name of the script we're renaming to the name we're going to give it, which is going to be wind chill comp, because that's what it's doing, is computing wind chill. And now we'll do another git commit. Renaming our first script is a good message for this. Okay. Okay, and now let's push it up to GitHub. So I'm going to stop my share for a second and get a terminal up, or get a browser window up for you. So please open a browser and navigate to GitHub while I do this. Okay, let's go to GitHub. GitHub.com. Okay, so first, to create a remote repository, you'll be on GitHub and you'll either need to create or log into your account, which should be somewhere over here on the right, top right. And so I'll give you a chance to create an account if you don't have one already. And you'll notice that there's this plus sign right here with the drop-down menu, and we're going to click New Repository to make this repository. If you need me to wait for you to make a name, a GitHub username, please ping for me to wait a second. If not, I'm just going to go ahead and click this button. Okay, great. Create new repository. So you'll see here you have an option to make a repository from a template. And this will be if you have other templates available to you. Sometimes that's useful. The owner is going to be yourself here, whatever your GitHub username is. And let's name it. So I'm going to give it the same name as the local folder, Python_tutorial_22. It's good practice for these things to share names across the local and remote locations. You can choose to set it to public or private. That is up to you. And you can choose whether to give it a description. So I will call this repository for summer 2022 tutorial series. Okay, it's pretty standard to add a README. But we'll do any of that stuff manually as we need to. So I'm just going to go ahead and click Create Repository. Okay, great. So GitHub is a great tool for organizing your software projects. It's kind of like, I could compare it to a Google Drive, except it's way more tailored to software, to being able to track versions of your software. So you could use specific releases or go back to specific commit histories. There are histories on other like text editors and things like that across the web, but GitHub just really hones in on what's important for software here and for collaborative development and ways so that you can have multiple editors on a project, but in a way that does not endanger the working condition of your project. And we'll kind of talk more about that in terms of pull requests and reviewers and all of that. But right now we're just creating a repository and we're the only person who can make or break it. Okay, so you're going to actually go back to your terminal at this point. But we're going to go ahead and get the URL for our code, which you'll see right here, this little copy button. You can also copy it from your URL line if that's what you like to do. Okay, I'll stop sharing one more time. And share the terminal. Okay. There. So we're going to do git remote add origin. And then paste the URL to your repository. Just like this. Okay, you hit enter, you didn't get any error messages, that's great. To make sure that things didn't break, you can type git remote -v, and this will show you all of your remote repositories. So we have our GitHub repository that we just created, listed both as where we fetch from. So that's if other changes were made on the GitHub version of your code, you could copy those down to here where you're locally working in the terminal. And the push, this is where we're pushing things to. So to now add our projects to GitHub, we're going to do git push origin main. So we're pushing up to origin. As you can see, these are named origin. We added it as origin. And we're pushing to the main branch. And maybe I'll tell you more about GitHub branches in a bit, but I don't want to confuse you too much now. Okay. So let's see if our GitHub is now up to date. Okay, I'm going to again switch my sharing. If you go back to your tutorial, voila. Maybe you have to do a refresh first to see it appear, but we now have our text file, which you can view, and you might have some syntax highlighting here on GitHub. And we also have our data folder. And here's our data again, if you ever want to revisit it. Okay, great. Now let's jump right into our heat index function. So back to the terminal. So our heat index script is going to be pretty similar to our wind index script in that we're reading the same data files. We're going to use the same dictionaries of columns and types. So a good starting place is just going to be to copy with CP the windchillcomp.py file, and we're going to copy it to a new location called heat index comp. Okay, you do an ls, see that they're both there. And let's just do a git add real quick of our new file. Our commit message can be copying first script to start second. Okay, I'm going to do a quick clear because that was a lot. Git status, git logs, you can see it all. Okay, now let's heatindexcomp.py. I started to type my sci again because I'm so used to this exact command. Okay. So the first thing we'll go ahead and do is go down to where we define our wind index function and just delete it and create a heat index function. Okay, so let's go ahead and delete these lines. Add a comment for compute heat index. And then name our function compute heat index. Now, heat index is a function of temperature and humidity. And now let's just go and copy or enter all of the variables that we need. So there's a lot. So I'm just going to call them A, B, C, all the way through I. Okay. And here are their values. Negative 42.397, 2.049, 01523, 10.14, 333, 127, 0.2247 5541, 0.0548 1717. Okay. So I missed one. Yes, I missed one. This is actually what F is equal to. Sorry. And E is 0.00. We're missing a space here. So it's a lot of room for typos right here. If your values are not exactly correct, it's going to show up in the comparison of our values, but it's not actually going to change the lessons that we learned here today. Like your code should still work if these values are wrong. I'm still going to try my best to type them in correctly though. Last one is .50199. Okay. And we're going to also have to use our humidity as relative humidity. So we just want to take our percent value and divide by 100. So we have it in a decimal value. And here is the heat index function. We'll create a variable HI for heat index, and it is a power series. So we have our first variable times the sum of temperature and relative humidity. So no, it is. Okay, we have our first variable, and then it's added to this term. Actually, sorry, I have things a little. It's added to B times T. And these are added to C times relative humidity. Then we get up in our terms. We are going to now have D times both of them. Okay. Let's see. We're going to actually do plus and then a slash so that we stay down on the correct line. And we're going to do E times T squared. So this is going to be our first time actually calling the exponent to the squared value. So that's double asterisk and then the value for the power function. Relative humidity squared. Now we're going to do one squared and the other not. And then reverse it. And finally, both of them squared. Okay, and make sure you close both sets of parentheses since we started out in one. And we're going to return our heat index value, 1, 2, 3, 4. Like that. Heat index is also known as apparent temperature. So using assumptions about vapor pressure, wind speed, your skin surface area, all of those radiative properties and sweating and all of that. There's this regression analysis formula that kind of takes what the temperature is and adjusts it for what it should feel like. So as you know, temperatures here in Colorado feel much different than they do in Florida. And so that's kind of the purpose of this analysis. Again, I was just kind of looking for something that we could calculate with the variables in the data file that was selected. But before we calculate our new function, before we actually run it, which hopefully some of the syntax was a little easier the second time we made a function here. Let's go all the way back to the top of the function, and we got to change the data that we're pulling out of our data file. So scroll all the way up. Okay. So let's go to the end of the file with Control E, and then instead of wind chill or wind speed, we're going to want humidity out, which is the 5th index. And we're going to go and grab heat index because that also exists in the file. And that is the 13th index. We go ahead and add a space here for consistency. And both of these are things we want as floats. So replace wind chill with heat index and wind speed with humidity, or specifically hum out. Okay, so now we have everything that we need for reading in our data file, writing our new function. But here where we actually call up our function is going to be different. So let's go ahead and rename this heat index. Maybe we could be more consistent about names from the beginning, so we can call it heat index comp if you want. Okay. And instead of temperature and wind speed, we're going to grab temperature and humidity out. Go ahead and change that here in both places. Okay, I'm actually going to call it just humidity instead of humidity out. Same way we're calling it temperature instead of temperature out. We're going to append our heat index list instead of our non-existent wind chill list. And our new function, which we're calling, has a different name. There's a pigeon right outside the window cooing. I'm not sure if you can hear that or not. Okay, and we're passing in the temperature and the humidity values for every value in our tuple, like so. And let's go and change our output of data as well. I'm going to change what the string looks like. So we really just have to change these values here from wind chill to heat index. It is still the right number of characters to fit on that line, which is convenient. Okay. And our zip data is going to look a little different here. So we still want data time. Now we're going to pull out heat index and add our computed heat index. Change these to HI for heat index instead of wind chill. Now, hopefully you're feeling that this copying and editing is slightly tedious, if not quite as tedious as rewriting everything from scratch. That's good that you feel that way, because then you'll understand the motivation for what we want to do next week when we go back and refactor our code, so that we do not have to copy and paste and trace down every single line that we want to slightly edit before we move forward. So we have one last line to change everything from WC for wind chill to heat index. Like that. Okay, and moment of truth, we're going to go ahead and run the script and hope that I didn't leave any syntax errors to go trace down. It is not called my site. It's called heatindexcomp.py. Okay, I did leave an error. It does not like the way I broke up my lines. Okay. Let's see. Let's go in.
I believe it has to be a backslash.
Ah, okay. Oh, oops, that does not exist anymore. Heat index comp.py. Scroll down to your heat index function. Sorry about this, everyone. Maybe you're having similar error. So I had that slash. Yes, we want it to be a backslash. And hopefully this fixes it. This is one of those things in Python that I just try to look an example because it's hard for me to remember exactly which way it goes. So I just have a little note and know that's backslash and have to check myself. Okay, let's try running that again. Okay, it worked. It looks like I definitely typed a value wrong because these different values are a little too big. Let's just scroll up and make sure our header looks good. Okay, I'm gonna find that error real quick. Okay. Those values are off the charts wrong. Okay, so. That one looks right. Okay.
Bill Brown suggests that maybe RH should be Hume divided by 10 or 100.
Oh, yes, it should be divided by 100. That is definitely.
Thanks, Bill.
Thank you so much. That definitely saves some headaches. Okay, let's try again. Okay, I still have something to track down. I know that we only have 5 minutes left today, so I don't know if that's the best use of our time right now. I want to give you a chance to ask some questions. And I know that I will find it because I have run this code before and have had the values much better than that. So I just don't know if it's the best use right now. So please go ahead and put in the chat some questions that you might have. Coefficients might be missing some minus signs. Okay, let's see. And then next week we will go into refactoring our code, which should hopefully be really rewarding and set us up to better add more scripts like that. Let's see. Yes, I'm missing some minus signs. That sounds about right. Can you run Git from a Jupyter notebook? Yeah, so you should still have a terminal available to you in Jupyter, and it should function much the same. And you can also run terminal commands on cells of your Jupyter notebook if you use an exclamation mark beforehand. Okay, let's make some of these negative. Sorry, not sure how I missed this. Okay, still getting closer. Any other questions before I end the recording and give you all a few minutes back in your day? Thank you all again for attending. Thank you for your patience with my internet connectivity problems, and typos. Just to review, we've mostly covered string indexing and made a new function today. Okay, Benjamin, so your GitHub does not want, it wants you to personal access token. Have you followed that link? And has it been helpful for you that it's pointing you to? I will also do a quick search. Okay. Okay, thank you. Yeah, that's okay. Let me just see if I can look into this a little bit. Okay, I will look into this and I will send an email out to everybody when I document a little bit, because it's gonna take me a second to read through this documentation. But actually, before we leave, let's do a quick Git commit or Git add. And a commit message. Okay, so I'm gonna just look up how to set up your personal access token, but before I do that, I'll just go ahead and end the recording actually and stop my sharing.